So we'll fill in the notes and then we'll look at the converse because that's the part that's new for you, right? So the first part, Cody, read the first note. I'm picking on you today. What would you guess? You think you could fill it in? The missing side of a right triangle. Well, actually, the interesting thing is we can find missing sides or angles, but we will start with sides. Mason, what are you doing on your computer? Read the second note for us. What are they called in a right triangle? Do we know? Anybody? It's the same as what we call the sides in a trapezoid. Legs. I thought maybe you would remember the trapezoid because you just did isosceles trapezoids. Okay, side C is called the hypotenuse. And then for any right triangle, this is where we're just writing out the Pythagorean theorem. So we are using it to find the missing side of a right triangle. Sides A and B are called legs. Side C is called the hypotenuse. For any right triangle, A squared plus B squared equals C squared. And the other thing I always point out to people, if you forget, the hypotenuse is a cross on the right angle. It's like the little right angle box is making an arrow to point at the hypotenuse. So I think most of you can do these problems, right? So I'm going to give you, can't see the clock, 8:41. At 8:45, I'm going to ask for some of these. You don't have to be completely done. Here's my challenge for you. Instead of making everything a decimal, simplify the radical. Answer in radical form. Especially if you're in Algebra 2. If you're not in Algebra 2 and you have no idea what I'm talking about, we'll go over it. Don't worry. Sure, if you already answered in a decimal, just also go back and see if you can figure out the radical. Because if you're in Algebra 2, I say, the reason I say, especially for you, is because if you take pre-cal next year, we don't make decimals, except in very few situations. Just now notice that it says right here, round each answer to the nearest 10. Yeah, well, you could do that too. Actually, you might should, because if you're like last year's class, most people could not round to the nearest 10. That will confuse the decimal place. And it was consistent enough that I'm imagining at some point there was a confusion in the teaching because it wasn't like one or two people. Yes, yes. Where's my water? Good question. Okay, 20 more seconds. Again, that doesn't mean in 20 seconds you have to be done. It just means in 20 seconds we will start sharing the first few answers to see if we're on the right track. Okay. All right. So finish the problem you're on. I'm giving the Jeopardy countdown. I'm not very good at it. Dun, 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 dun. Okay, so for question number 1, do we have a volunteer? Sonette. 15 point. Square root of 233. And what did you say as your decimal? So for the 10th place, we would only have one decimal. So did you say 15.26? Say again. Did I write it correctly? So if we're going to the 10th place, it would be 15.3. If you're doing the radical form, it would be square root 233. So if you're not clear, radical form, this little symbol right here is called the radical. So when we put something in radical form, we leave it with a radical, whether it's a cube root, a square root, a 10th root, whatever. Number 2, do we have another volunteer? No? Conan, did you do number 2 yet?
Yeah.
What'd you get?
34.8.
34.8 is rounded to the nearest 10th. What did you get for radical form? Did you even try? Yeah, I wasn't sure if you tried to simplify that. It does not simplify. Do you guys know the shortcut for like knowing if a number can be divided?
No. Tell us.
If it has a 3 at the end, I just divide it by like 9, because if it doesn't divide by 9, and if it's an odd number, it's probably not going to divide.
Interesting. There is actually like a whole list of what we call divisibility rules. You're right, like it's an odd number, right? So we know it's not divisible by 2, which would mean it's also not divisible by 4, 6, 8, etc. Because those are even numbers. But to know if something is divisible by 3, you add the digits. So for this, I would do 1 plus 2 is 3, plus 1 is 4, plus 3 is 7 divisible by 3?
No.
Then this number is not divisible by 3. If it's not divisible by 3, it's also not divisible by 6 or 9. Did you know that's a rule? So if you have a big number and you're trying to figure out, am I going to be able to simplify this? You can check quickly for 2 and 3. If it's not even, that takes out 2. If it's not, if the digits added up is not divisible by 3, then the number is not divisible by 3. So then you just have to worry about weird things like, is it divisible by 13 or 17 or something strange? But it still narrows it down for you. Anyway, just a little tip for you. Number 3. Mental, do you have number 3? 5.7. So if you're not getting these answers, please ask, like if you got something different, let's check why. Did you do the radical? Root what?
But that can also be simplified.
Root 32 can be simplified. By what?
4.
4 square root of 2. 32 is the same thing as 16 times 2. 16 can be square rooted to give us 4, and we're left with a 2 inside. If you haven't simplified radicals much because you're not in Algebra 2, you'll get more practice next year when you do take Algebra 2. And by the time you get to pre-cal or AP calculus, you'll just do it in your head very quickly and easily. Okay, number 4 looks pretty simple, so let's skip that one for now. Number 5. Did anybody do number 5 yet? And so what'd you get? 21.3. What'd you get for the radical? Yes. So 21.3 is correct. If you're stuck, notice that it's like the triangle is cut in half. So this is X, and this side right here would be 11. And then this one is 24 because it tells us they're equal. So that's what we're actually finding. We're using half of the triangle, and that's okay. If you weren't there yet, don't panic. Looking at number 6, notice that it's kind of like a rectangle and a triangle. This is actually what we would call like a composition, 2 shapes together. But we can't find the X using just the rectangle, so we're actually going to use this one at the right angle. And then we need to figure out what would be the length from here. Just this part. If you saw what I drew right here, what's that length? That's what we need to find X, because it's a rectangle, this part is X also, right? So did anybody already find this piece right here? What is it? 13. How did you do that? You have 18, and we know this part is 5. So we can just subtract. 18 minus 5 means that's 13. So we have the 13, we have the hypotenuse is 16, and we're looking for X, right? And then on number 7, we actually have 2 right triangles. You have to do this twice. Think of it as like this side right here is A and B, or if you don't want to use those letters because they're in the Pythagorean theorem, just pick 2 other letters. We could make this M and this M. Like this side of this little triangle, I can call M, and this side of the other triangle, I can call N. I'm doing 2 different things to find those 2 parts, because notice that X is the whole thing. So X would be M plus N. Anna, is today your first day back? No, you were here yesterday? Oh, I was gonna say welcome back, but I didn't see you yesterday, so welcome back anyway. So, does that make sense? Nod your head if you are like, yes, it's fine. Turn your head in circles if you're like, no, I'm lost. Did anyone do that? Can you like rotate your head? I hope not. That would be a bad time. Anyway, I'm going to leave you to do number 8 and 9. Try to break up the shapes. Skip to number 10. It's word problems. We're not going to work out all of these right now, but I will tell you that the one thing you need to do is draw the picture. So a roofer leaned a 16-foot ladder against a house. If the base of the ladder is 5 feet from the house, how high up the house does the ladder reach? So like, here's the edge of my house, and there's a ladder that this person leaned up against it. And I know that the ladder is 16 feet. This is funny because this is not very scaled. Look, here, we'll make it longer. 16 feet, here's the house. And we know that this right here is 5 feet because it said 5 feet from the house. And so the question is, how high up the house? We're looking for this as X. Now, what's the assumption? We're assuming that the house was built straight. The wall makes a 90-degree angle with the ground. Obviously, that's an assumption because the ground may not be completely flat. It might have built the wall a little crooked, whatever, but we're just going to go with perfect situation. So then once you draw the picture, you should be able to quickly see that I'm just going to do X squared plus 5 squared equals 16 squared, right? So you're going to draw all those pictures. Now, finish whatever you're working on. I can see you all working hard. I'm going to give you 30 seconds to finish and put your pencil down. Cody, I can see you. 30 seconds, 20 seconds. Because we're going to go to the next page and that will be new for you and you'll need to write down very clearly what I'm saying. And then you'll have the rest of the time to work and finish up. 3 seconds.
Hello.
I said to finish the one you were on, not start the next one. Turn the page. Turn to the next page. Everyone should be turning their packet now. Hi, Soation, what's up?
So how would you like us to round the word problem? Our answers in the word problem.
Yes. Can you hear me?
How would you like us to round the answers in the word problem?
Okay, we're going to the next page. 8.1b. What's the title say, Ikshan? I can't hear you. Yell really loud. I'm sorry, the topic, the objective on the worksheet. Can you see it? Okay, so we're using the converse. So Ishan asked a good question about rounding your answers in the word problems. Go ahead and use the 10th place. If you're familiar with significant digits, scientifically speaking, you would look at, I'm going back, don't turn your page back. I will show you some examples. In number 10, all of these are whole numbers. There is no decimal place. So generally speaking, we wouldn't have a decimal in our answer unless we were told what to do. We would use the same amount. Look at number 11, same thing. There's whole numbers. But then if you come to number 12, each of these has one decimal place. So your answer should have one decimal place. And then in number 31, again, you have whole numbers. So generally speaking, we would just leave it as a whole number. Doesn't mean that you have to. Usually in a class, the teacher will tell you. But in science, we learn about the number of significant digits in a problem dictates how many digits you should have in the answer, because the answer can only be as precise as the values that you had to start the problem. I don't know if you guys have learned that, but hopefully. Awesome. Good. So you could apply that logic if you're not told specifically round to the 10th or leave it in radical or whatever. You could use that same logic for science because math and science often work together. So let's jump to this page. Remember, we know what a converse is because we did that whole unit on logic and now you're all so brilliant, right? Here we go. These are all random facts that are true. We accept them as true. If you don't accept it, we can get you some mathematical videos to watch all the proofs. If c squared equals a squared plus b squared, then the triangle is, what kind of triangle? It's a right triangle. If you notice that one, the Pythagorean theorem is just sort of written backwards. We usually say a squared plus b squared equals c squared. It's just kind of reversed. It's like reflexive property. It's a right triangle. Here's the part that's new for you that's interesting. If c squared is greater than a squared plus b squared, then the triangle is obtuse. Remember, obtuse is bigger than 90 degrees. And then in the other way, if c squared is less than a squared plus b squared, then the triangle is acute. It's a cute little triangle. See, that's how I remember that. So this is the part that's new. This is what we call the Pythagorean theorem converse, because it gives us information about the triangles. And what you will notice, this part right here is a little note. Always keep c squared on the left side to avoid confusion. That's more like a note of like, if you tend to get confused about the less than or greater than symbols, this is a good idea. Keep c squared on the left, because then you can immediately see if it's less than or greater than, and you know the answer, what it's supposed to be. If you are not, if that's not a problem for you, then it's not like a rule. It's just a suggestion, okay? So let's look at an example. Here's the directions. First, determine if the three side lengths could form a triangle. Do you guys remember how to know if it could even make a triangle? Tell us. Oh, I was hoping you actually remembered it. I didn't keep reading. My bad. Go ahead. I cut you off. Read it.
The sum of the two smaller sides must be greater than the third side.
Remember when we did that earlier this year? So first, you would just check. 3 plus 7 is 10. 10 is bigger than 9. So yes, this is a triangle, right? Then classify the triangle further as acute, right, or obtuse. So what you would do is 3 squared plus 7 squared. And look, I'm already breaking the suggestion. Put C on the left. 9 squared, 3 squared plus 7 squared. And I'm putting a question mark here because I don't know if it's equal, less than, or greater. What is 9 squared? 81. On this side, I have 9 squared, or 3 squared is 9, plus 7 squared is 49. What's 9 plus 49? So which is it? Equal, less than, or greater than? Starting with 81. 81 is greater than 58, which means this is what kind of triangle? Obtuse. So you see the idea of what's happening here? Well, do we need to do another one? Or are you comfortable to finish them on your own? What do we think? Try another one. Try number 2. For number 2, you notice that 20 plus 21 equals 41. 41 is greater than 29, so it is a triangle. And then I have 29 squared. And then I have 20 squared plus 21 squared. You actually have to show your work. So when I say show your work, you are allowed to use a calculator, but what I want to see is basically what I have written on number 1, and then on number 2, this side is 841, this side is 841. It's equal, that means it's a right triangle. So I've written this statement that we're looking for. I've written the answer, and then I've chosen a cute right obtuse. That's showing your work. I didn't have to show that I did each square and then I added, etc. But that's it. I will give you a hint that there are 2 problems that are not a triangle. 2 problems that are not a triangle. And after you finish this page, you finish the application problems, you finish these, I guess it's technically 3 pages. You have one other remaining assignment for today, tonight, however you want to look at it. For this lesson, it's a Delta Math assignment. It is linked on Google Classroom. And it says Pythagorean Theorem Converse. So it's very specific. Tomorrow we're doing an activity in class and it's a shorter class. So I don't know if we'll have extra time. But you could do Delta Math, finish it all by the 4 o'clock tomorrow, or finish it sometime tomorrow or the weekend.